Hey everyone, welcome back to the channel. So again, today we'll be doing the problem of the day for today and we'll be doing it live. So the heading is minimum operations to make array values equal to k. So we are given obviously we are given an array and we have to make all the values equal to k. Maybe we are given an integer array nums and an integer k, something like this. An integer h. So there's this third thing h. It's called valid. If all values in the array that are strictly greater than h, so all the values which are strictly greater than h are identical. Okay, all right. For example, if you have 10, 8, 10, 8, then a valid integer is 9. Why? Because all the values which are greater than 9 are all equal. Say, but for example, if I was talking about even 8 would have been a valid integer, right, over here, but 7 wouldn't have been. Why? Because values which are greater than 7 are not all equal. So you have two different values, 8 and 10. 5 is not a valid integer. You are allowed to do what? You are allowed to select an integer h that is valid for the current values in nums. Okay, so you select an integer h, could be anything, but what I'm guessing is probably if I had 10, 8, 10, 8, then the first thing which I'll go for is 9, obviously, right? So you sort of pick the largest number and then you go one level down, right? That makes a lot of sense. For each index I where nums of I is strictly greater than h, set that particular nums of I to h. Okay, and at the end of the day, I think what we have to do is make all array elements equal to k, return the minimum number of operations which are required to make every element in nums equal to k. Now, one thing, if it is impossible to make all elements equal to k, return -1. Why? Why would it be impossible to make all elements equal to k? You see, just like in this test case, you have to make all elements equals to 2, but there is no way in which you can make this particular element equal to 2. Why am I saying that? Take a pause, think about that. Because all that you can do is take the existing array nums and decrement its value. You cannot increment any value, right? You cannot increment any value. Similarly, you have 9753 and you have to make all of them equal to 1. You can't do that. Select 8 or maybe select 7. Okay, make this equal to 7. Then select 5. So that, let me just count how many operations I'm doing. You select 7, you make everything equal to 7. So it becomes 7, 7, 5 and 3, right? 7, 7, 5 and 3. Then you select 5, second operation. Then you select 3, okay, third operation. And then you select 1 and you make all of them equal to 1. So that's why you are taking 4 operations, right? Similarly, over here you have 5, 2, 5, 4, 5. So 5, 2, 5, 4, 5. First thing which you can do is take 4 and make all of them equal to 4, right? First operation. Then you take 2 and make all of them equal to 2. So 2 operations, isn't it? So one thing which we actually learned from the test cases is that you don't it would be better for you if you do not take any random valid integer h. If you take one from the array itself, then that's going to prove very useful to you. It's going to save you a lot of tries. So you have 9753, right? So 9753, how is that going to look like? Let's see. 9753. So we said the first thing which we are going to take is 7, so that this becomes 7753. Then we said we are going to take 5, so it becomes 5553. Then we said we are going to take 3, so that it becomes 3333. And the k which was given to us was 1. So in the fourth operation we take 1 and then we make all of them equal to 1. But you see, if I had chosen a valid integer, so this is my particular combination, my particular selection of the valid integers h which I was choosing. But for example, if I had chosen 8, then what would have happened? This is the original array, right? What would have happened is this 9 would have become 8, right? So 8, 7, 5, 3, and then I would have had to select 7 itself, because again 7, 7, 5, 3. You see, so a thing which I can do in just one instruction over here, I would have if I had chosen 8, I would have had to do the same thing in order to get the same result, in order to get to the same state or the same stage, I would have had to do two operations. When the valid integer which I had chosen was not part of the array, it was outside the array. So I'm guessing that and not guessing, actually it's a fact, I think mathematical fact, that it would prove for you to be better if you choose an integer from the array itself. And okay, one thing, another thing, you see, I have 9, 7, 5 and 3. Okay, I could have had many instances of 9. For example, what was that test case? Let's see. I had 5, 2, 5, 4, 5. Okay, so 5, 2, 5, 4, 5. Just think about it. You don't care about how many instances of 5 you have, right? Because in one operation you can change every instance of 5 to 4, right? 4, 4, 4, and the k was 2. Then you select k equals 2, you make all of them equals to 2, right? So what would be a good approach over here? A good approach would be that I take a map, right? And I count the frequency. So I have 5 how many times? I have 5 3 times. I have 4 how many times? 4 I have 1 time. And then 2 how many times? 2 I have 1 time. Okay, now my k is equals to 2. So what am I going to do? The good thing about a map is that it automatically sorts the keys. So this is an integer comma integer mapping. I'm mapping an integer to another integer, right? So I have 5 3 times. Okay, the first operation that I'm going to do is I'm going to take this as my valid integer, right? This as my valid integer. Then I'm going to take this as my valid integer. And if, for example, the good thing over here is that the k was 2, so I only had to do 2 operations. If the k was something else, for example, if the k was 1, then I would have had to do +1 operations, right? That's it. So map.size is actually 3. I'll just subtract 1 from it, and then I would check if the least number is equals to k, then just return true, else return 2 plus 1, something like that. And that would work over here as well. You have 9753. What is map.size? Map.size is 3, and then your k is actually different as compared to your least number. If k was 3, just think about it. If k was 3, you would have had to do one less operation. So you would just have returned mp.size -1. But since k is different as compared to your least integer, then you have to return 3 plus 1. Why? Because you'd have to do one extra operation over here. So yeah, this. And again, a very simple check would be that when the least number that you have, if k is greater than that, then do not do anything, just return -1, right? So what I can do is I can just calculate minimum element, something like this, or I can say min element, something like snake case. Min element is equals to steric min element, and I'll just give it the iterators for nums.begin and nums.end, right? Something like this. Okay, I have figured out what the minimum element is. I'll say if k is greater than the minimum element, then just return -1, because it's not possible for you to do any processing, right? You won't actually be able to make all the array elements equal to k. Okay, what next? I take a map int comma int, and I could actually take an unordered map as well, but the sorting doesn't really matter over here, right? So I'll just you could take an unordered map as well. The won't actually make that much of a difference, but you can. For int I in nums, what I'll do is I'll take mp of I plus plus, and just for that matter, you could have taken a set as well, because all that you care about is the number of unique elements that you have. So you could have very well taken a set as well, and we'll do that implementation as well, don't worry about it. So acha, one minimum element I already have. Okay, right. So what I'll do is I'll return mp.size -1. Okay, this is one thing, and then I will see if the minimum element is equal to what, if it's equal to k, then I'll have to if it's equal to k, then I won't have to add anything, right? So if it's true, then add nothing, but if it's false, then add 1, right? So let's see if it passes all the test cases, right? It does, and it probably will pass all the other test cases as well, right? So the other implementation would be that you take a set of int st, and then rather than taking the frequency of every element, you just do set dot insert, right? And then you do the same thing with set. So if I run this code, it's probably going to get accepted as well. Not probably, it's 100%. Sorry, 100% to 100% going to get accepted as well, right? Okay, right? Perfect. So if we take a look at the constraints were very low. This was an easy question, but if we look at the time complexity over here, then the time complexity is clearly O of n, because we are first of all, minimum element is going to take O of n time. Then we are iterating over all the numbers and we are inserting them in a set. So that takes O of n time. And over here, since we are taking a set and we are storing all our elements inside of that set, then we are taking O of n extra space as well. So that was the time and space complexity. This problem of the day was actually quite easy, but nonetheless a very good question to solve. And I hope you found this video helpful. I'll see you in the next one.